In this video, we want to look at the binomial theorem. And this theorem seems a little bit kind of out from the rest of this chapter, but it really is a series, and that's how it connects in with our series, and we have a formula for our series. Now, if you remember, binomial is something like x plus 1. So there are two terms. That's what binomial means. And what the binomial theorem does is give us, if we have x plus 1 to the first, well, that's just x plus 1. If we have x plus 1 squared, then we'd have to FOIL that, and that is x squared plus 2x plus 1. But let's say we had x plus 1 cubed. That would be x plus 1 times x plus 1. Now, I'm just going to say, for all of you that are the box method people, it's going to be a lot more work to do this with the box method. And the idea here is we'll eventually get to where we don't have to do this, but just follow along. So first, we're going to FOIL these two, which we just did a second ago, which is x squared plus 2x plus 1 times x plus 1. And now we distribute, and this would be x cubed plus x squared. That's this one times both. If we do this times both, that is 2x squared plus 2x. And then the final one, if we take that, we get plus x plus 1. So our final answer is x cubed plus 3x squared plus 3x plus 1. Now, what the binomial theorem is going to be a way for us to get here a little bit easier, quicker with a formula. Now, at first, it may not seem quicker, and for one that's simpler like this, it may not be quicker, but I think you'll see where we're going here as we get going. So here is our formula for the binomial theorem. If we have an a plus b to the n, so if I go back, just so we understand this here, in this example, my a is my x, my b is 1, and my n is 3. So that's how that would connect. And then this is the formula we are going to have. And you'll notice what it does. It starts with a to the n, b to the 0, a to the n minus 1, b to the 1, and so forth. And then the term in front is this NCR, where it goes from 0, 0, 1, 2, 3, and so forth. You will notice that number on the C is the same as the exponent on the B. That will become useful later. Now, this NCR is something, for those of you who have had stats, you have seen this before, and we're not really going to worry about what it actually represents. We're just going to do it on the calculator. And luckily for us, this is built into the calculator. So if you go to Math, you go to Probability, you go down to NCR, and you can type this in. 7, let's go 7, 4. Okay. Some of you, if you have an older calculator, you'll need to hit the 7 first, then go to Math, then do NCR, and then hit the 4. And in that case, it won't actually look like a subscript like this. It will just be more 7C4, but it still works. So that's what these, and what these are, these represent the coefficients in front of each term. Okay, so these represent the coefficients in front of each term. So let's look at an example. So let's say we want to do our x plus 1 cubed. Okay, remember our a is x, our b is 1, and our n is cubed. So the terms we got to find, 3c0, 3c0 is 1, 3c1, 3c2, and 3c3. So let's write those out here, and I'll come back here. So what we would have here, let me go back to here, is this would be 3c0 x cubed 1 to the 0 plus 3c1 x squared 1 to the first plus 3c2 x to the 1 squared, and then plus 3c3 x to the 0 1 cubed. Now you will notice these pairs of exponents here always add up to 3. So as I do this, I don't really think of this formula at the top. I just start with 3 on the A term, 0, and then it goes 2, 1, 1, 2, 0, 3. So you just kind of count down. Now, our 3c0, you can see right here, is 1, and then anything to 0 is 1. So this is just x cubed. Plus 3c1 is 3x squared. 3c2 is x to the first 1 squared, which is just 1. And then 3c3 is 1 plus x to the 0, which is just 1 cubed, which is 1. And you will see we end up with the same thing that we had here. So as this exponent gets bigger, and if we actually tried to FOIL this out, it would get harder, that's where this binomial theorem is a little bit easier to do. So let's look at an example. 3x minus 4 to the 4th. My A is 3x. My B is negative 4. Notice our formula is always plus. And my n is 4. So I need to figure out, just kind of do all of them at once here. I need to do 4c0, 4c1, 4c2, 4c3, and 4c4. So I will just do one of these in the calculator. We'll do 4c1. If I go here, 4c1, we get 4. So that is 4. If we did the rest, we would get 6, 4, 1. So now let's write down our terms. This is going to be our first term of 1, 3x to the 4th, negative 4 to the 0. And you can see going forward, this many times I will not even write this because that's just 1, but we'll write it here. Plus 4, 3x cubed, negative 4 to the 1st, plus 6, 3x squared, negative 4 squared, plus 4, 3x to the 1st, negative 4 cubed, plus 1, 3x to the 0, negative 4 to the 4th. So you can see, once we know the coefficients, 1, 4, 6, 4, 1, really we just kind of count down. The 3x goes from 4, 3, 2, 1, 0, and then the b, the negative 4, goes the opposite, 0, 1, 2, 3, 4. So I don't really do this by looking at the formula. So now here, 3x to the 4th is 81x to the 4th. Here we have a negative sign, so this is going to be 3 cubed times 4 is 432. I did these ahead of time. Plus here the negative squared goes away, so we multiply those out. This is 864x squared. Here the negative is going to stay around, so this is minus. This is 768x, and then plus 256. So you can see by using the binomial theorem, this is much easier to multiply out and to get our answer than by trying to do this by FOIL and by hand. This series, this formula gives us a series. Adding terms together is much easier. And just to show you how this would work out, if we would actually go to Wolfram Alpha and type in 3x minus 4 to the fourth, and it actually multiplies it out for us, it gets our 81x to the fourth minus 432x cubed plus 864x squared minus 768 plus 256, which is what we got. Now, instead of having to expand the whole thing out, one thing we'll do on homework is we'll say, find the coefficient in front of this term, just in front of the b term. So if we think of this, my a is 3, my b is b, and my n is 5. So if I wrote this out, this would be 5c0, a to the fifth, b to the 0, plus 5c1, 3 to the fourth, b to the 1. And I'm going to stop there because you can see right away this term would be my b term. And as I said earlier, just kind of in passing, you can see to help you figure out these coefficients, whatever this number is on the C is the same number that is on our second term, that is B. So if we go 5C1, if you put that in the calculator, you would get 5. So this would be 5 times 3 to the fourth times B, which is 405B. So what is the coefficient of the B term? That is 405. So instead of writing out all of them, we want to find an individual one. Let's take another one. What is the third term of the expansion of y minus 2x to the fourth? So this is 4c0 of y to the fourth times negative 2 to the 0 plus 4c1 of y cubed negative 2 to the first plus 4c2 of y squared negative 2x squared, and then that is our third term. So 4c2 is 6 y squared negative 2 x squared. That would give me 24 y squared x squared. So that is my third term. Now, another way we can do this, besides using this binomial theorem formula, is we could also do this by using something that's known as Pascal's triangle. Now, Pascal's triangle is this triangle which has ones down the diagonals, and then to find this term, you may have seen this before, to find this term, we add the two terms above it. So to find this 2, we take 1 plus 1. 1 plus 2 gives me 3. 1 plus 3 is 4. 4 plus 6 is 10. 10 plus 5 is 15. If I wanted to go to the 7th row, this would be 1, 7, 21, 35, 35, 21, 7, 1. And what these rows are of Pascal's triangle are our coefficients. Consider when we looked at here with the third, we had 1, 3, 3, 1. And if we go back to Pascal's triangle, you can see the third row is 1, 3, 3, 1. If we were looking at the fourth, here we had 1, 4, 6, 4, 1. So our fourth row is 1, 4, 6, 4, 1. So all that Pascal's triangle does is it gives us these terms, this C and R. It doesn't help us with the A's and the B's, but it does give us those kind of coefficients that go in front. So we have this, we know this. This is actually pretty easy even to just, figure out. If you're doing one of these problems and you have, you can pretty quickly go 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. It's almost quicker than even getting the calculator to do the C's to get these rows, okay? So an example, we want to do x cubed plus 1. So once again, we know our A is x, our B is 1, our coefficients are 1, 3, 3, 1. And we do the same thing we did before. We have 1 x cubed b to the 0 plus 3 x squared b, sorry, not b, let's put the 1 in there like it is. 1 to the 0, x squared, 1 to the first, plus 3x1 squared, plus 1, x to the 0, 1 cubed, and we get x cubed plus 3x squared plus 3x plus 1. Same way, it's just a different way of getting our coefficients. So let's say we had x plus 2 to the 4th. From our 4th row of the Pascal's triangle, we have 1, 4, 6, 4, 1. So 1, 4, 6, 4, 1. So this is going to be 1, x to the 4th, 2 to the 0, plus 4, x cubed, 2 to the 1, plus 6, x squared, 2 squared, plus 4x 2 cubed, plus 1 x to the 0, 2 to the 4th, and this is x to the 4th plus 8x cubed plus 24x squared plus 32x plus 16. So 2 different ways that you could do this. Now you got to be a little bit more careful if it is a negative. Okay, this once again is 1, 3, 3, 1. So this would be 1, 3x cubed minus 4 to the 0 plus 3, 3x squared minus 4 to the 1 plus 3, 3x to the first, negative 4 squared, plus 1, 3x to the 0, negative 4 cubed. And hopefully you're recognizing the pattern. That initial formula, I think, makes it look really complicated. But it's not that bad if you just kind of get in that pattern, right? So as we said, this is kind of different than what we've been doing, but really this is just a series. You're just adding terms together, and there's a formula or a pattern to those terms, which how this connects with what we have been doing. Now, another thing that we will get is how to do the coefficients of just an individual term, right? And don't forget, once again, when you're doing these, if you're unsure, always you go to Wolfram Alpha and you're trying these on homework and whatnot, you can check to see if you're getting the right things as you do this. So here it's asking for the x cubed term of x plus 2 to the 8th. So in my case, I am going to do this by 8c5 x cubed 2 to the 5th. Now, if you want to remember, how did I know this? In some ways, you could think of it this way. If I was going to write this out and I want to find the x cubed term, this is going to be x cubed 2 to the 5th, because I know those have to add up to 8, and then this exponent on the b is the same as right here. So 8c5, if I put that in the calculator, I get 56. X cubed 2 to the 5th. If I combine those, I get 792 x cubed. Now, you also could find this 56. This is the 8th row, the 5th term. We could go back to here, and if I wrote down the 8th, this would be 1, 8, 28, 56, 70, 56, 28, 8, 1, 0, 1, 2, 3, 4, 5. This is our 5th term, which is 56, which is the same thing we got there. So multiple ways of getting that coefficient. So this homework will include both find the coefficient of a term, find what a certain term is, and just expanding out an expression such as this.